In this problem, we're asked to complete the square of the quadratic function g, given here, and then use that form to describe how one might go about finding the graph. This is a degree 2 polynomial, so we know that the graph of this ends up looking like a parabola. But exactly how to lay this parabola out on the graph paper is not obvious when you first look at it. I mean, we can see some details. This will have a y-intercept of -16. Since this leading coefficient is positive, we expect the graph to be a parabola opening up. But some of the other key details is, where is the vertex, and how does this graph compare to, say, our standard x squared function. And by completing the square, we can see some of those details. So we're going to do a little algebra first, figure out the form of the function g that has the form necessary to describe it as a complete square. And there's a couple of ways you can go about this. A leading coefficient of 1 here is nice to work with. So I would begin by factoring out a 2 and thinking about the piece that's left over. But there is an option here, so that's right away we have options. We can choose to factor the 2 out of everything or out of just the first 2 terms here. And either way you can find a solution to this, but because I want to discuss something in a couple of moments, I'm going to proceed with factoring out of everything. So if I pull a 2 out of 2x squared, I leave an x squared behind. If I pull a 2 out of -12x, I got a -6x in here. And again, another reason why I don't mind pulling the 2 out is because it comes out of this last term easily. But what this allows me to do now is just consider this piece separately. So what I want to do is try and write x squared minus 6x minus 8 in a form that is a square of some linear term here. This will just be x plus or minus a constant squared plus or minus some other constant. And with the leading coefficient of 1, we can always do this. By filling in these 2 blanks appropriately, we can rewrite the expression x squared minus 6x minus 8 as x plus or minus something squared plus or minus some constant. Each of these will be constants. So our job now is to figure out which constants go in here, and I take care of that investigation one by one. And we can just kind of guess and check what needs to be here so that when I square this out, I end up with the x squared, the 6x, and the 8. Well, if you think about it, what this constant determines is the value that ends up being placed on the x. It's not exactly the same, but that's what this will, that will affect. If I multiply this out, I'll have an x squared, and I end up with twice 2 times x times whatever constant sitting here. I want to end up with -6x. I want the x. So twice the number that's sitting here needs to end up being -6. If we flip that around, we would say that the number that needs to go in here must therefore be half of -6. So -3 is the quantity I want in there. And let's just write down here how this would expand. So let's multiply it back out. I still have this constant out here to contend with, so I've got this blank I need to still fill in so that I can actually have equality here. But if I multiply this back out, I've got an x squared minus 6x so far and a plus 9, and then still this constant. So I get these 3 out of when I square x minus 3. The x squared I wanted, the minus 6x I wanted. I want to end up with a -8, however, and I ended up with a plus 9. So I'm going to need to adjust this by adding or subtracting something here, and that will also go up in this blank up here. I want to end up with -8. I'm up at plus 9, so I need to subtract the 9 to get rid of that, and subtract another 8 to get me down to -8. So overall I would subtract 17. So whatever goes there, and then I'll just do the arithmetic to make sure I end up with equality all the way along the line. 9 minus 17 is -8. So that is the same as this. So all of these forms must be the same, including this one, which is the desirable one. I will now bring that back to G. So G is twice what I have over here. So there's an x minus 3 squared minus 17 inside here. And this form here is easy enough to read in terms of understanding what the graph looks like. This may not perhaps be the easiest way, but this is a way. Again, at the basic building block function we're dealing with here is the parabola x squared. This minus 3 would shift the parabola 3 units to the right. Again, when you subtract 3, it's going to move it to the right 3 units. And if that's tricky to remember, think about where the origin would go. If I want to put 0 into x squared, I want to get a 0 out. And if you ask yourself, what do you need to put into here in order to get that 0 out? The answer is 3. So the 0 on x squared has been moved over to positive 3, which means again a shift right of 3 units. Order of operations here had me start inside like that. The next operation I would do is subtracting the 17. And the 17 is acting on the result of this calculation, so this is going to be a modification of my y values. This then will be a shift downward of 17 units. I'm subtracting 17 from all my y values. So I've moved it 3 units right, 17 units down, and then the last calculation I would do is to multiply by 2. That will double all of the y values, and that would have an effect of vertically stretching the graph, but it also moves the vertex. The vertex was down at negative 17, if you tracked what we were saying before. So if I multiply that by 2, it ends up at another location, twice that distance, so negative 34. And it might actually be easier to think about this using an alternate order of operations by doing a little bit of algebra here. Let's multiply the 2 through. And now with this form, the sentence we need to write is going to be something somewhat different. Both of these, however, are acceptable forms for this. But the form you're staring at will modify the sentence that you end up writing. Both of them end up with the same graph, however. The order of operations on this one would have us shift right by 3 units. Then the next operation would be to multiply by 2. So this is the vertical stretch by 2. And then the last step would be to move it down 34 units. Again, they end up in the same place. Try graphing both of these and see that it happens. I'll graph this final form after writing my sentence. So again, I start my sentence with, I will start with the x squared function and then first thing I'll do is shift it 3 units to the right. Then stretch it vertically by a factor of 2. And finally move it down 34 units. Alright, now I think we're only required here to draw the final result, but I'm going to show you piece by piece each step.